Oh yeah, go.
To what extent can math be beautiful? Can it be understood in a similar fashion like the arts? If math has an element of elegance, does this jeopardize its level of certainty? Explained by myself and Kurt Jacoby.
Oh, didn't see you there. This is a epic math lesson from Kurt and Tanner moment. So the first concept and question we're going to be talking about is for the question, can math be beautiful? And the first concept is polar functions. Now, polar functions are in reference to two-dimensional coordinate systems in which a point on the plane is measured by a distance from a reference point to another angle. And this gives us the distance of a radius. And this is all done in radians, and you use theta and angles to figure out this thing. Now, on the calculator, to make a polar function, you go to mode, polar, and radians, make sure it's all in that. And then once you do that, you go to your y equals and plug in a function consisting of y equals 1 plus cosine of 6 theta. And that will get you a graph or function that looks like a rose or petals of a leaf. And that is called a polar rose. End. Okay. So the polar rose, as seen right here, Q zoom in, as seen right there, it's very beautiful and looks like a rose. And that's why the polar coordinate system is very beautiful, because we can use certain formulas like the one I previously said to create this beautiful mathematical graph of a polar function. And that's why they're beautiful, because the polar function graph reminds us of nature. And nature in our eyes is beautiful, and the roses are even more beautiful because they symbolize love, and love is beautiful. Now, in regards to the final concept and new concept, it's graphs. Graphs and pie charts and bar graphs, they're all beautiful because they can tell a story. Similar to how art can tell a story, this right here is math because it can tell a story in a very beautiful and design aesthetically pleasing way.
Second question, can math be understood in a similar fashion like the arts? The answer is yes. Math in itself is a form of art. We can see this in graphic design and infographics. As you can see right here, we have lots of geometry, lots of parallel lines, lots of perpendicular lines, and lots of symmetry. Without math inside of logos and all of graphic design, it would just be a mess of uneven shapes and patterns that don't make any sense. Right here you can see the word target is all spaced out correctly. That's thanks to math. You can see the perpendicular and parallel lines in the Domino's logo, and you can see the symmetry of the NBC logo. Without any type of math, this would be impossible, and all of these logos would not look as aesthetically pleasing as they do, and they wouldn't therefore make as much money. Math is art. As we can see here, this is not graphic design, this is not made on a computer. This right here, both of these are drawn by Da Vinci. The Last Supper. I was unaware of all the geometry and symmetry within this painting, but as you can see by all the little boxes, Da Vinci spent a lot of time making sure things were spaced evenly out, making sure Jesus was dead in the middle of the table, and all the disciples were on each side. All the columns are spaced evenly throughout, and without that, this painting would look a lot less aesthetically pleasing, similar to graphic design. As we can see here in his famous painting of the dude with the circle, there's lots of geometry and symmetry in this painting, whereas the circle and the man's arms go in different directions. His arms in this painting are set at different angles, as well as his legs, as the square and the circle help that happen, and those are shapes, geometry. If math has an element of elegance, does this jeopardize its level of certainty? Yes and no. Statistics shown on a graph can sometimes be misleading if the graph is made with too much elegance. Poorly made graphs can ruin the validity of mathematics. As we can see right here in this graph, it says most first-round picks by a school in the Common Era. This makes no sense because this graph should not be made into a pie chart. They do not equal 100, and this is not a percent of anything. It looks like USC has a large portion, but it really doesn't make any sense. This is how the graph should look, and it shows that USC and Ohio State are very similar. Miami is in the middle, and Florida and Alabama are together. This graph shows the real validity and doesn't look as nice, but this graph is fake but looks nicer.
So, as you can see here, we have the sine graphs and the cosine graphs. They look very nice and they are completely valid, which means they have this level of elegance that does not take away from their validity because, as you can see, very elegant flower, valid polar function that creates a beautiful piece of flower art.
A counter argument for this claim may be that math is just math, and it is a coincidence that it is sometimes visually pleasing to the eye, and that math is not a form of art.
Regardless of the fact that it is coincidental, you cannot deny the fact that the math is beautiful in of itself, and that art and math are just beautiful, and beautiful lies within the eye of the beholder.
Who's the rest? Math is math, it's just a coincidence that's elegant.